Hello, fellow gamers. I'm Diabeticus, and this is episode 5. Last episode, we have found the two pseudo-foci of x cubed, which is plus minus 2/5 of 4th root 1 over 45, and plus minus 4th root of 45. Now that we've located those points, what else is there to do? Well, based on the title, we're generalizing. Generally generalizing. By which, I mean, instead of starting with x cubed, let's start with f of x, where my visual example is a chibi cat. Anyways, in one entire episode, we'll briefly speedrun and redo everything the past 4 episodes, but with less numbers and more abstract letters and fruits. So prepare yourself. In part 2, the start for us was to find the equation of a normal line, and again, let's establish the variable apple as our main guy. Remember that our normal line equation goes by the form y equals m times x minus x1 plus y1, where y1 and x1 are positions and m is the slope. The positions x1 and y1 are simple enough. x1 is just apple and y1 is just the y value, f of apple, alright? Now for the slope m, we took the derivative of the function to find the slope. For our general case, the derivative of f of apple is simply no different, f prime of apple. And f prime of apple is nothing special, it just means derivative of f. But the slope f prime apple is along the point apple, f of apple, not across. So to make the slope perpendicular, we do /1, flip, and slap a minus. -1 over f prime apple. Thus is our slope m. So we now have y equals -1 over f prime apple times x minus apple plus f of apple. Okay, that's the generalized part 2 segment. Now, zooming in to part 3, we now want to use this normal line equation to find the intersection of two closed normal lines. To do that, let's establish a new normal line equation, y equals -1 over f prime pair times x minus pair plus f of pair. Now, we find the POI of these two equations and prepare for some massive algebra. Since the left y's are already done, let's equalize the two right-siders and perform the consecutive steps once more. Number 1, distribute the slopes to have x terms. Number 2, transfer the right x to the left for factoring. Number 3, take the f of apple and the apple over f from apple and transpose them to the right to have left only x terms. Number 4, factor an x to have x only on the left, which makes number 5. Divide both sides by the left factor. Now, to simplify this equation, we apply the identity a over b plus c over d equals ad plus bc all over bd, and apply that to the denominator. And after that, we take the bd and multiply it to both numerator and denominator. Then we simplify further, so we have this will be our equation. Next, we do the y equation, the apple one. Now, this is the part where we yeet the entire x to solve for y. This time is necessary, so prepare yourself for the second wave of algebra. Okay, having substituted the entire x equation, multiply the inner apple by f prime apple minus f prime pair all over f prime apple minus f prime pair, so we can include these factors to the big x fraction. Next, we expand the new factor, and there should be a cancellation in the big inner fraction. After that, we take this outer apple and make a join the inner parenthesis club. And to do that, let's examine the expression ab plus c. And if you want to include c to the inner guy, we divide c by a and place it inside. So check this one out. A times b plus c over a equals a times b plus c. These should be equal. Now, let's apply this identity by subbing c as f of apple, a as the slope factor, and b as the big fraction. With that, let's divide c by a and place it inside. Alright, after we unsubstitute c and a but not b, we then multiply the c over a variable by f prime apple minus f prime pair all over f prime apple minus f prime pair to include it in the fraction. We then unsub b. After that, we expand that term's factors as well as the other factor pair, and then we cancel. Lastly, we divide the other f prime apple, ending up with this expression for y. Since we now have the pure apple expressions of the POI for both x and y, take a look at this animation where any two normal lines across the cat graph will exactly locate their intersection utilizing the two gargantuan expressions that we toiled for. That is the first half of part 3, because the next thing we did is take the limit as pair goes to apple. And remember, closed normal lines create their POI closer to the cone surface of the normal map. And oh boy, just by looking at either equation you might ask yourself, how in the world do you even take the limit from this? Hint, you can. But the process is very tedious and took hours to figure out. And because of that, taking the limits of these equations deserve their own video. In which case, I will be sacrificing the good vibes of progression and skip this limit part to, prevent mental declension and to save time. And speaking of saving time, I will also shorten my use of notation, where every f of apple is just going to be called f, and f prime apple is f prime, and so on. Pretending we did solve for the limit, the x equation is apple minus f prime cubed plus f prime all over f prime prime. And our y equation is f plus f prime squared plus 1 all over f prime prime. Brilliant! Now we have these two equations that represent the POI of one normal line for a value x equals apple. Though if we speak of every POI for every normal line for every value of apple, we get the parameter that forms the shape of the cones. These are what the cat graph's cones look like. And this is part 3 abridged. Now for part 4, where we use the minimum and maximum of the y component to find the minimum and maximum of the cone graph, because again, the y component has the same range as the cone. And to find those values, we will have to go through derivation for that guy and equate it to 0. So, time for more algebra! Hooray! And a lot of derivative rules too! To begin, our y equation is f plus f prime squared plus 1 over f prime prime. And let it be clear that derivation works individually for each term, so our first term is simply f prime. Now, the fear is encased in the second term. It's horrid. I may not explain clearly what chain rule or quotient rule is, but bear with me. So, starting with quotient rule, our calc teacher taught us one sort of mnemonic for this rule, where it's low d high, less high d low, low low, where low is the denominator, high is the numerator, and the d's are derivatives. Using that identity, we have f prime prime times the prime of f prime squared plus 1 minus f prime 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 times f prime squared plus 1 over f prime prime squared. Next, we evaluate the prime of f prime squared plus 1 using some chain rule. And chain rule is simply pretend that f prime is just a regular x to regularly derive, turning f prime squared to 2f prime. Then for some reason, sneak in a derivative of f prime, which is f prime prime, and factor it to the expression, yielding 2f prime f prime prime. Since 1 is a constant that dissolves to 0, the prime of f prime squared plus 1 is just 2f prime f prime prime. Following that, multiply the first term by f prime prime squared over f prime prime squared to have it join the fraction so that when we equate this to 0, the f prime prime squared denominator cancels out. After that, we transpose the triple prime term to the right, making equality where we get 3f prime prime squared equals f prime 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 times f prime squared plus 1. And solve for apple? I mean, we're supposed to, right? Well, yes and no. Remember, we're generalizing, which means that the f primes and the f prime primes are just mere variables and there's nothing much to it. And because of that, our solution for apple is just, well, the solution of this equation, period. Now, remember that our supposed apple solution to this equation is the apple value of which we plug to the y component to get the pseudo-foci y value? Well, this apple solution also applies to our x component because both components of the parameter depend on the value of apple. And since we do not have an algebraic apple solution, we can plug things to the x and y equation. They just stay as they are with their f's and apples because this is what generalizing is. No numbers whatsoever. Lastly, remember that this apple solution is, or are, also the x values of our original f of x, of which the normal line crossing it directs us to the pseudo-foci by the parameter. And for a bonus, these are every pseudo-foci of the cat graph. There are more than one if you haven't noticed. In summary, the formal way to find the pseudo-focus is as follows. Number 1, find f prime x, f prime prime x, and f prime 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 x. 2, solve for x in the equation 3f prime x, f prime prime x squared equals f prime 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 x times f prime x squared plus 1. Number 3, plug the solution to the x component. X minus f prime x cubed plus f prime x, the 2 over f prime prime x. Number 4, plug solution to the y component, which is f of x plus f prime x squared plus 1 all over f prime prime x. 5, express the obtained values from 2 and 3 as a coordinate. Now that we have been furnished with these informations, let's use these steps to an example. An easy one, x squared. So, step 1, find f prime, and f prime prime prime. Using the power rule thrice, x squared becomes 2x, 2x becomes 2, and 2 becomes 0, respectively. These are our derivatives which we then plug to step 2. When we do, the right side amounts to 0 because the third derivative is 0, and swiftly, the left side becomes 3 times 2x times 2 squared, which is 24x. Since 24x equals 0, our x is basically 0. On step 3, plugging 0 to each x, we get 0 minus 2 times 0 cubed plus 2 times 0 all over 2, which I think the answer is 0, right? Now on step 4, plugging 0, we get 0 plus 2 times 0 squared plus 1 over 2. This simplifies to 1/2. Then, on step 5, we create the coordinate from the components, giving us 0, 1/2. If we plot the PF 0, 1/2 with a parabola and then show the normal map, we can confirm that this point is indeed the pseudo-focus because it's at the tip. Now for this finale, I never told you directly why the pseudo-focus is called the pseudo-focus, but now all shall be revealed. So do you remember your conics? That for a parabola ax squared, the focus, and I mean the real focus, is 1 over 4a of distance from the vertex? Well, our a for all x squared is 1, so 1 over 4a is just 1 over 4. And 1 over 4 is the distance of the focus from the vertex 0, 0, making the focus point 0, 1/4. As you can see concretely on this graph, The pseudo-focus, which is clearly 0, 1/2, is not the focus, which is 0, 1/4. This makes it the focus that is fake, therefore forming the name pseudo-focus. And tell you what, the pseudo-focus also differs from the focus of a hyperbola and the ellipse, but exclusively not the circle. Though finding the focus is limited to only conic sections, the pseudo-focus applies to any graph, whether it be a function, a parameter, or a polar coordinate. Wait, did I just include parameters and polar coordinates? Oh shoot, I spoiled it.